Okay, so in this video here, we're going to be talking about how to factor using substitution by u. Now, you can use this method if you have the following pattern. Let's go back to a quadratic in standard form. That way I can kind of describe this pattern to you. If you have ax squared plus bx plus c, the pattern that we're looking for is a pattern of doubling. So for example, on this term right here, my exponent on that variable is 1. Notice that I'm doubling as I go to this term right here. So right now I have 1 and then I go to 2. So if you have that pattern of doubling, you can do substitution by u and you can essentially factor it that way. So if you look at the example that I have up here, again, it's very similar to a quadratic, but again, it's not a quadratic. But I do have that pattern. Notice my exponent here on my variable is 2, and then I'm doubling it. I go to 4 right here. So I can use substitution by u. So let me explain to you how it's going to work. Let me go ahead and get rid of all this here. It's fairly straightforward, and it can be very useful for factoring polynomials. So this term right here in particular is what you want to look at, your middle term here. And notice that you have x squared. That's what you're always going to be setting u equal to. Whatever your variable and exponent is right here, you'll always be setting u equal to that. So for example, on this problem here, I'm going to say u is equal to x squared. And then from here, you're just going to go ahead and substitute in. So wherever you see an x squared, you're going to plug in u. Now right here, I have x to the 4th power. So think about how I can rewrite that. I can write that as u squared, right? Since u is x squared, well, if I do u squared, that will give me x to the 4th power. So I'm going to say here u squared and then minus 4. Now here's an x squared. Go ahead and plug in a u and then plus 4, okay? And from here, you can go ahead and factor it. You can see that I'm dealing with a quadratic. So what we're doing is we're manipulating it, right? And once we're done manipulating it, we'll go ahead and resubstitute back in what u actually is. So at this point here, I can do the AC method, a times c, okay? My a value here will be 1, and my c value is 4, so I get 4 when I do a times c. So I need two numbers when I multiply that will give me 4, but add up to negative 4 right here. And that's going to be negative 2 and negative 2, right? Negative 2 and negative 2. When I multiply them, I get positive 4. When I add them, I get negative 4. And since a is equal to 1, I can put this right in factored form. I'm going to say u minus 2 and then u minus 2. And now we're going to go ahead and resubstitute in what u actually is. In this case here, x squared. So I get x squared minus 2 and then x squared minus 2. And then from here, you're done. You can go ahead and clean it up. You could say x squared minus 2 and then all to the 2nd power because I have two of those factors, right? So that's completely factored and you're done. That is substitution by u. So that would be my final factorization right here, okay? Let's go ahead and try another example. Okay, so here's our next example, and before you try to do substitution by u, you always want to try to pull out a greatest common factor. Now, on the first example, I could not pull out a greatest common factor, so I didn't even try. But on this one here, you could possibly pull out a greatest common factor, and if you look at it, you could pull out a 2. So I'm going to go ahead and pull out a 2. So pulling out a 2, that will give me x to the 6th power minus 4x cubed, and then plus 3, okay? And so now you can see that I have that same pattern. I'm doubling, right? I'm going from 3 and then to 6. So we're going to go ahead and use substitution by u on this polynomial right here. So we're going to say u is equal to, it's going to be x cubed here, right? X cubed. Remember, we're always going to be using this variable and exponent right here, okay, when we do substitution by u. So from here, we're going to go ahead and replace. So I'll go ahead and rewrite the 2. And then right here, I'll have u squared minus 4u and then plus 3. And then again, we're going to do the AC method here. So a times c, again, I'm working on this quadratic here. I get 1 times 3, that will give me 3. And now I need two numbers when I multiply that will give me 3, but add up to negative 4. That's going to be negative 3 and negative 1. And since a is equal to 1, I can go ahead and put it right in factored form. So I get the following. I get 2. And then I get u minus 3. And then I get u minus 1, close it. And now, finally, we're going to go ahead and resubstitute back in what u actually is. u is x cubed. So I'm going to go ahead and rewrite as 2 and then x cubed minus 3. And then I'll get x cubed minus 1. And you can stop here, but technically on this factor right here, this is a difference of 2 cubes. You could actually keep expanding this if you wanted to. But for the sake of this problem here, we're going to leave it like that. We'll call that done. All right, so here's the complete factorization right here. Okay. Again, just keep in mind that on this factor here, technically you do have a difference of 2 cubes and you could keep expanding it out, but we're going to stop right here. So let's go ahead and try one more example. So here's our last example. And again, you want to try to pull out a greatest common factor. On this one here, I can pull out a 6. So pulling out a 6, and then I'll get x to the 8th power and then minus 3x to the 4th power, and then I'll get plus 2. Okay. Again, I have that same pattern of doubling. I'm going from 4 to 8, so I can use substitution by u. I'm going to call u x to the 4th power. So u is equal to x to the 4th power. And then rewriting it, you get 6. And then u squared minus 3u and then plus 2. And then from here, we're going to go ahead and factor this quadratic right here. So doing a times c, that will be 1 times 2. You get 2. So I need 2 numbers when I multiply, that will give me 2, but add up to my negative 3 right here. Well, that's going to be negative 2 and negative 1. When I multiply them, I get positive 2. When I add them, I get negative 3. A is equal to 1. I can put it right in factored form. So I'm going to say the following. I get 6, and then I get u minus 2, and then u minus 1. Okay? Now we're going to go ahead and replace u with what it actually is. So we get 6. And then x to the 4th power minus 2. And then we get x to the 4th power minus 1. And from here, this one's actually a bit interesting because with this factor here, you can actually keep expanding that out. That is very similar to a difference of 2 squares. We're going to expand it out the same way. So for example, off to the side here, I can expand out this factor by saying x squared minus 1 and x squared plus 1. That will give you the same thing. And then technically, at this point right here, you have another difference of 2 squares. So you could keep going with the problem. You could say x plus 1 and x minus 1. And then again, this factor would come down, x squared plus 1. And then that would be completely factored. So putting it all together, you'd have the following. You'll have 6, and then you'll have x to the 4th power minus 2. And then we're going to include all these factors here. X plus 1, x minus 1, and then finally x squared plus 1. And there it is. Here's the complete factorization. And we're done. All right. So that is substitution by u. I hope that you found the video helpful. I hope that you gained something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that'd be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.